Welcome to Implicit Differentiation Aggressive Solving. So we're going to solve some more aggressive differentiation equations where the answers are going to take a little bit more algebra in order to get there. Mel's getting aggressive too, so let's dive right in. So we want to find dy dx. So much so, yawn. It's going to be, in getting that dy dx by itself is going to be a little bit of a bear. So what I like to do, especially if I'm a little nervous about my differentiation, is I like to write out what I'm doing. I'm looking for d over dx, the derivative with respect to x of x cubed, plus the derivative with respect to x of y cubed, which equals the derivative with respect to x of 18xy. Great. Okay, let's do the easy one first, that x cubed. All right, well, that's just going to be a 3x squared. No trouble. Easy peasy, because we're finding the derivative with respect to x. We get to the y cubed, we are going to need to apply the chain rule. So we would get 3y squared, so that's just the outside of that y cubed, multiplied by the derivative of the inside. So the derivative of y is just y prime, or the derivative of y with respect to x. Neat. Okay, other side of the equal sign. We got a two-parter. We got a product rule. Let's do it. We got the 18x, and we got this y. Those are the two things being multiplied together. So the derivative of 18x is 18 multiplied by our second thing, which is y, plus the derivative of y, which is just going to be dy dx, multiplied by the other thing that was in there, which is 18x. Great. Okay, next, we now need to try to solve this thing for dy dx. So what I want to do is, especially since I've got all these variables going all over the place, I want to make sure that the one I'm solving for is on a single side. So I'm going to move, I think I'm going to move these two onto the same side because they both have a dx in it. And I'm going to move it over to the left-hand side. Why I'm moving it to the left, I don't know. It's the pick a side. It just doesn't really matter. So let's see. We've got 3y squared. We'll have that first. dy dx. And then we're going to bring this 18x dy dx over to the other side. So it'll be negative 18x dy dx. And we want this to be the dy dx side, club. So sorry, 3x squared, you're going to the other side. I don't know if I got those lefts and rights right, but what you're going to do. So we get 18y minus 3x squared. Cool. All right. Now, here's why I wanted to do that. Now that they are on the same side, even though I can't put those together, they are not like terms. One of them's got a y squared and one of them's got an x. What I can do is I can factor out that dy dx. I can pull it out of them because they're both being multiplied by it. So this dy dx, I can pull that out, make it dy dx multiplied by those two things. 3y squared minus 18x. Just like that. And then on the other side, we've got 18y minus 3x squared. Nothing changed there. What I like about this is now I've got just a dy dx. It's got some junk attached to it. I can just divide that away. Nice. Let's divide it away. It's a bunch of stuff, but we can still divide it away. All right, so our final answer here is dy over dx equals 18y minus 3x squared divided by 3y squared minus 18x. Think about Steve. Sorry for headphones. Well, I can just edit that out. There. Well, future me will. Then what you might see in a multiple choice is they may, because like you might be tempted to cancel. The only thing that we can really cancel is if it was multiplied by that whole thing. So we could factor out a 3 and make it a 6y minus x squared over 3y squared minus x. And then those 3's would cancel. But you don't really need to. I only show you this in case you were working on, say, a multiple choice question and the multiple choice question simplified it. So this wasn't an option, but this was. Then you would need to know how to, like, ooh, I could take that out. Don't cancel the y's. They don't cancel. We got loosey-goosey subtraction in that problem. All right, let's try this example. Here we got to find dy dx, and we're going to find the second derivative, d squared y over dx squared. So once again, I'm going to go through my terms, and one by one, I want to find the derivative of each one, d over dx of y squared plus d over dx. Oh, I didn't change colors. Oh, well. I like to change colors. It's fun to do that part. Plus d over dx, and then a 1. Neat. Okay. Easy one. That's 0. Another easy one. That's 2. And then next we've got 2y. I need to find the derivative of that. Applying the chain rule, would drop the 1 down and multiply it by the 2, so that's a 2. Then we'd have a y to the 0. Y to the 0 would just be a 1, so that's gone. And then we'd have dy over dx. I'm going to be doing a bunch of solving with this, so I'm just going to make a little change. I'm just going to make it a y prime. Just for the ease of my notation, if I wanted to, I could do dy over dx. In your notes, if you want to do dy over dx, you could. But remember, y prime means the same as dy over dx. But just for difference's sake, I'm gonna do it that way. So this is 2y multiplied by, and I do like to use that multiplication symbol, so I'm not tempted to put them together, y prime. Okay, so 2 plus 0, I'm pretty sure that's 2. And then just like we did in the last example, I am going to factor out that y prime. So I get y prime, and then we get a 2y plus 2. And then I can divide both sides by that. So y prime, or you could also say dy over dx, because those mean the same thing. It's just different ways of writing it, equals 2 over 2y plus 2. And this we could like factor out a 2 and do a little canceling. And so we could clean this up to be 1 over y plus 1. Let me get rid of that negative so we don't, or a little tick, so we don't think that it's a negative. Okay, great. Now we need to find the second derivative of this thing with respect to x. We're still going to be finding the derivative with respect to x, which is going to be goofy because we only have y's now. There's no more x's. Ugh. So I am going to change the way this equation looks a little bit before I take the derivative. So I am going to make it equal to y plus 1 to the negative 1, just to make it a little bit clearer how to do the chain rule and stuff. So I take the derivative with respect to x of y prime. Well, and we've done that before. Usually when we just have a y prime right there and we're finding the second derivative. So it's like, oh, cool, great, double prime, we did it. And remember, this means the same as d squared y over dx squared. Now, to find the derivative of this next part, we need to make sure that we're applying the chain rule properly. We need to drop the -1, so that's -1, multiplied by, oh, well, wait, well, y plus 1, and then a -1. And then we need to do the derivative of the inside. So the derivative of 1 is 1. The derivative of y would get us just a 1, kind of like that 2y up above. So there's my derivative of the inside. But remember, I need to apply the chain rule a second time. So I would need to get a new y prime. But I don't really like that as a y prime. I don't like that. Oh, wait. Ooh, I forgot to subtract. That should be 2. I don't really like that as a y prime. So I'm going to use the y prime I got already. I'm going to move over here. This one. So we'll put this right here. So this is 1 over y plus 1 multiplied by this piece, which is 1 over y plus 1 squared, multiplied by this thing, which is -1. Oop. So y double prime, or d squared y over dx squared, equals -1 over y plus 1 to the third. And that's done. That's done. So reminder with your implicit differentiation. Can I go to the next page? Oh, nope, 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 nope. I'll go back. With your implicit differentiation, that means that you're finding the derivative when y is not by itself. So just do implicit divide, differentiate each term one by one, and remember that the derivative of y is going to be y prime or dy dx, and use the chain rule whenever you come across a y. Thanks for watching. Bye bye.